My interest in science started when I was a child. Early in my kindergarten, I was playing with dinosaurs and evolved into a chemistry set in my during my primary school, and some explosions there and things that worry my parents. And with good teachers, I was driven and canalized into biology. Legionnaires' disease is a severe form of pneumonia caused by the bacteria Legionella pneumophila. This bacteria is normally found in fresh water and will contaminate human water sources, will be aerosolized by cooling towers and air conditioning, will reach our lungs, and there the bacteria will infect our respiratory tissue, causing this severe form of pneumonia. Unfortunately, the incidence of this disease is growing, and every summer we have more and more cases. It's considered a burden for health in industrialized countries, where pneumonia caused by this bacteria is the second most common form of pneumonia admitted in intensive care. The study of Legionella disease is an interesting field of research. It's very challenging. We need to learn a lot about the ecology of these environmental bacteria, and then try to understand why these bacteria will become a pathogen in humans. And it's very important to collaborate between different areas of expertise and with different researchers to solve this important health problem. The grant for Ontario Lung Association and Pfizer is critical for us because it will give us support to continue our research and move forward. It's nice to see new generations coming into the lab and help them, the students, to find their and find their vocation and help them in develop as the new generation of scientists.
I wanted to do something to help individuals who experience shortness of breath. And there really were few options and very poor understanding of the underlying mechanisms. For the last 20 years or so at Kingston, at the Respiratory Investigation Unit here, we've made fairly strenuous efforts to better understand the experience of shortness of breath and to intervene meaningfully to relieve this very distressing symptom. In preliminary studies, we identified many patients with COPD who had weak muscles of breathing, and we wondered whether specific training of these muscles would help in terms of improving their shortness of breath. The particular device that we used is this one here. And in essence, it's a resistive device which patients breathe through. They inspire, and there's a resistance that they have to overcome before they can generate inspired flow.
I've had asthma the majority of my life, ever since I was a little kid, and I was diagnosed with emphysema in 1994. I think by using the machine on a regular basis for that period of time, I had fewer and fewer episodes of shortness of breath. And I was told that I was strengthening the muscles of my diaphragm and chest. And so all of a sudden you could get free air really easily as you broke that threshold. And that was what I was always shooting for, to get that threshold higher and higher and keep on getting to that point.
When we see and understand better the mechanisms involved, it's a great feeling, because it does translate directly into improvements for the patients. COPD exacerbations or infections are the commonest cause of hospital admissions in Canada. So these sort of awards are very important for people like me and my team who are making every effort to try and improve their situation.